Alright, so for this lesson, we are learning how to divide polynomials using long division. Okay? Of course, when you get to algebra 2, there's another method called synthetic divisions that will be covered later in high school for sure. But for now, let's do a quick review of how to do long division problems. For instance, if I have 567 divided by 21, for instance, right? How do you do that? Okay, how do you set this up?
21 outside.
You put 567 inside the house.
Okay, 567 goes inside the house, 21 goes outside. So let's get going. How do we start?
2. See how many times?
Okay, so you see how many times what?
21.
Okay, so how many times 21 can go to 56, right?
2.
So you said 2 times, fine. So 2 times that, so 21 times 2 is?
42.
42, which makes it, and then we subtract, is that true?
14. Yeah. 14.
Which is 14, and then we,
Oh,
okay. Please understand and memorize the step that we're doing here, because this is actually something that you have been doing a long time. Bring down to 7, and then we start the whole process again. 21 goes into 127, right? How many times? 77? Let's try that. 7 times 1 is 7, and 7 times 2 is 14. Subtract it, and you end up with 0. Ooh. This is a good problem. The remainder is 0. So our answer is just basically 27. But assume that we have a remainder. How do you represent that in the past?
R.
Okay, you put R and then whatever the number is, right? For today, though, I'm going to show you another way to represent remainder. I'll show you in a bit. It's just a format, really. Okay, so don't get panicked when I say, oh yeah, this is how we represent our remainder this time. Okay, but it seems like you understand and you know how to divide, which is great. With that in mind, I'd like you to go and try to do this problem using the technique from yesterday, meaning factor, cancel, like terms. Go ahead, do that. I want you to find the area, find the width of this rectangle, and you know that the area is x squared minus 3x minus 18, and the length of this rectangle is x minus 6. How do we do this? How do you find the width?
Divide.
Okay, what?
Area divided by length.
Area divided by, go ahead. Area divided by length. So if you set this up, it's important that you have to write it. Area, that's the area, divided by the length, right? So just go ahead, set it up, and see what you have for me. What question do you ask here for the first?
Is it in order?
Is it in order?
Yep.
It is. Okay, next.
Greatest common factor.
Is there one? None. It's 3 terms. Is there a PST? Okay, then is there a PST?
No.
No. So Xbox, right?
Yeah. Negative 18 on top.
What, Jamie?
Negative 18.
Negative 18 on top?
Negative 3 above.
Okay, what times what is negative 18 add up to negative 3? 6, 3, but which one's the negative? 6. Do we need a box?
No.
No. Okay. So if we expand this, what do you have?
X minus 6.
Okay, x minus 6.
And then x plus 3.
Good. Bottom? What's the bottom going to be?
Dots. Wait, no. Wait,
Is it already factored?
No.
Look at the bottom. It's already factored. How do we know that? Look at the power. It's 1. We know that, right? Every time it's 1, we don't have to do anything about it. So x minus 6. And notice that as an extra step, I put an extra parentheses to kind of line up with it, right? And so, do you see anything in common?
Yes, x minus x.
What's left over?
X plus 3.
And this represents what?
The width.
The width. So you can now say the width is x plus 3. Right? So this is our old approach that we learned. And actually, you're going to be using this for a long time for this chapter. But for this particular lesson, though, I'm going to show you another approach. And this approach is called the long division approach, Jamie. Okay? So what I'm going to do is I'm going to use the same exact problem. And I'm going to show you how to divide it. So we have x squared minus 3x minus 18. Divided by x minus 6, right? Okay? So pretend that this is actually a division problem, just like what I gave you before. Which one will go in the house?
X squared.
Minus 3x minus 18, right? And of course x minus 6 will go outside of the house. Okay, now does it look like a division problem to you? Yes. And this is how we do it. When we divide this, will we have multiple terms? outside, we just care about the first term, the variable term. We use that as our, our main multiplier in a sense, and ask the question when we say, here's x. X goes into x squared how many times? Or another way to ask that question is, x times what is x squared?
X.
See it? So it's a lot easier if you ask that question. X times what is x squared? You say x. Once we have that x, because we have two terms, we have to multiply this x into both terms. It was just one term, and you just multiply x by x, right? But when we have both terms, it's like you're distributing x back to the x n minus 6. So what is x times x going to get you?
X squared.
X squared. What is x times negative 6?
Negative 6x.
Negative 6x. Okay, do you see that? What do we do after we obtain this? Think of your division problem. Subtract. So, once again, because we have two terms, we don't just subtract one, we have to subtract both. So we put the subtraction sign, and I put the subtraction sign for both sides. Now let's subtract. What is x squared minus x squared? 0. What is negative 3x minus negative 6x? This is where confusion will start to happen, because people always forgot about double negative will turn back into a positive. So technically this problem is like negative 3x plus 6x, right? If you are confused, I would definitely advise you to write it out. Oh, it's negative 3x minus negative 6x. So minus negative becomes a positive. So it's like negative 3x plus 6x. You see it? That becomes what? 3x. So down here is 3x. Does it make sense?
Yes.
Okay. Now that we have this answer, what do we do next for a division problem? We bring down the negative 18. So watch what happens. I bring down the negative 18, and the whole process starts all over again, just like a regular division problem. So I ask this question again. X times what is 3x? 3. So a positive, right? So I make sure I put positive or plus 3. And then we distribute again. 3 times x is 3x. 3 times negative 6? Negative 18. And what do we do once we obtain that? Subtract. Subtract. Watch what happens. 3x minus 3x? 0. Negative 18 minus negative 18? 0. So we're gone, right? 0 remainder. And check back to our answer again. Look, is that the same thing we got before? X plus 3. And this is called the long division approach. And you might ask me, well, Mr. Norwood, if we can factor and cancel it out, it's a lot easier. Why do we have to use this approach, right? Here's the answer to this. What if you cannot factor? It's not factorable at all. I mean, you cannot have anything that you can cancel out. Then does that mean you're stuck? No. This is where your long division comes in handy. You can actually divide whether or not it's factorable. Okay? So, look at the approach here. Looks pretty simple, right? I hope that you, as long as you remember how to divide, you should be able to set up a long division problem and divide polynomial. Okay? So with that in mind, let's take a look at our first problem here. And by the way, long division is actually best when you have when you divide multiple terms. We're talking about like something polynomial divided by a binomial outside, for example. But it's actually not good when you divide by a monomial, like in this case right here. You have a polynomial on top divided by a monomial on the bottom. Yes, and you can still argue and say, can we still do a long division problem on this? Yes, you can. But it is more complex. Instead of doing something like that, I want to bring your attention to this particular example before I go back to this. Remember in the past when you first learned how to add fraction for the very first time? 3/5 plus 7/5. How do you do that? Add across. Do we need to find the LCD? No. So technically speaking, isn't it just basically 3 plus 7 over 5? And so you add it with 10 over 5, which is 2, right? Watch what happens. Won't this thing here looks kind of like that? Where you can actually go backwards and split your two terms into, your 3 and 7, two separate terms sharing the same denominator? Look at this right here. Does it resemble this? It has 3 terms on top with the same denominator. If I go backwards, can I just split them all apart? Yeah, if I split them apart, this problem on top will now look like this. Watch. 9s cubed t squared over 3s squared t squared minus 15s squared t over 3s squared t squared. plus 24t cubed over 3s squared t squared. Is that the same thing? Because if you have the same denominator, you can always write it as one time and then combine the time only, right? And that's what you get as a result. Is that true? But why are we going backwards this time? Because if we go backwards, for this kind of problem, it's a lot easier for us to look at each fraction here and try to simplify. Look at this. What's 9 over 3? 3. Top or bottom? Top. S cubed and s squared.
S on top.
Top. T squared,
None.
none. So basically it's just 3s, right? Or 3s over 1. Fine, you can write it that way you want to, or just write it as 3s. What about over here?
5.
5, top or bottom?
Top.
Top. What about s?
Cancel.
Cancel, so I don't care about s. What about t?
Bottom.
Bottom. See that? It's a lot easier. What about here? 24 and 3. Top or bottom?
Top.
Top. What about s squared?
Bottom.
Okay, yeah, nothing gets canceled, but it stays in the bottom. What about t?
Up.
Up. And that's it. You're done. So this is the one case where you don't need to use long division at all. You just split them apart because it's shared. As long as it's shared the same denominator, just split them apart and then try to cancel each case and put them all together. Okay? So when you have a polynomial divided by a monomial, like multiple terms divided by just one term, it's better off if you just split them into each case and simplify. You only use long division when you see a problem that looks like this. Polynomial divided by at least a binomial or more, meaning 2 terms or more. Okay? So now that we have this problem, let's set up a long division problem. And the reason we have to use long division problem this time because that right there is not factorable. If you try to factor, you can't. Okay? Therefore, we're going to have to use long division on this. And as I write this out for you, what do we put inside the box?
6x.
Very good.
Third.
6x to the third
Minus.
minus 9x squared. Watch what happens, please. And I have 2x minus 3 outside. What is strange about this problem? What did I do that kind of jumps out at you?
This is space.
There's a gap. Okay. Why did I put a gap right there? Yes, Justin.
Because you don't have an X.
Very good. Nice catch. Do you realize that if you have to keep things in order, you have 3, 2, but what happened to the 1? Because usually you have power of 3, power of 2, then the power of 1 before you go to the number which has the power of 0, right? So the x is completely missing from this problem. For long division to work though, every term has to be accounted for. Every term. If it's missing, you better have it filled in regardless. So what do I mean by that? You look at this right here and say, wait, it has 3, it has 2, but x1 is missing. Is that true? So if that's missing, you have to fill it in. And this is how you fill it in. This space right here, I'm going to put x1, but since x1 technically doesn't exist, instead of putting a 1 in front of it, because if you put 1x1, that means it is a 1. It's a 0. Very good. So if it doesn't exist, you put a 0 right there. Serve as a space filler. That's all. You have to put it there. Okay? So one thing that you need to remember every time you do long division is if any term is missing, you have to fill it in with a 0, just to have it there, and the associated the correct term to it. So now that we have that filled in, we can start the process again. We look at the term outside and we start asking the question. 2x here times what is 6x cubed?
3x.
3x squared. Very good. 3x squared. And what do we do with the 3x squared? Distribute. So we distribute that. We guarantee to have 6x cubed, and 3x squared times negative 3 is? Negative 9x squared. What do we do after this? Subtract. Don't forget, if you put subtract, I have to subtract both terms. And let's subtract. What is 6x cubed minus 6x cubed? 0. What is negative 9x squared minus negative 9x squared? 0 as well. So basically I have nothing left. And then what do I bring down next? Bring down the 0x1, right? And I start the whole process again. 2x times what is 0x squared? I want a 0. 2x times what is 0, basically? 0. So basically, I can add 0 to it. But there's no point because they're both 0 anyway, right? So You can say, oh yeah, I add a 0 and I have a 0 here. I still have, subtract, I still have a 0. Then what's the last step? Bring down to 6, and there's nothing else you can do. 6 is your remainder. And this is how you represent your remainder. Look. Oh, by the way, there's no point adding 0, right? It's the same thing, so I can just go and take it off. Is that true?
Yes.
But this is how you represent your remainder. Your remainder, you have to add it to your solution and put it over your divisor. And that's how you put your remainder. Remainder over your divisor. Okay, and you add it into your answer. What do you think of that? It's a long division problem. Okay. All right, I want you to go ahead and try this problem on your own and see what you can do with that. Here we go. Here's the problem. Go ahead. Set it up. Okay, so don't forget, if you're going to set this problem up, you've got to spot right away that there is no T1. Is that true? It's missing. So when you write it as your long division problem, you have to take that into account and put in a spot for it. There, this is 0t spot. And now the negative 1 will follow. You don't have that, your problem won't be correct. Okay? And you have 4t plus 1. Right here, outside. Alright, so just like always, what do we do? What are we checking for? The first term only. 4t times what is 4t cubed?
14 squared.
Okay, think about this. If you're going to put 4t squared, 4 times 4 is 16.
T squared.
Ah, check it, right? So we know that it's just t squared, right? T squared times 4t is 4t cubed. T squared times t, times 1
1t
is 1t squared. Agree? What do we do here? Subtract, subtract. And then I subtract. 4t cubed minus 4t cubed? 0. 17t squared minus 1t squared?
16t squared.
16t squared. And then what do I do here? Bring down what?
0.
The 0t. See, this is the reason why you have to have it there. Imagine if you left it out, then you have nothing left to bring down except for a negative 1, and all of a sudden your answer got all wrong. So bring down to 0t. There it is. And then we start the whole process again. 4t here times what is 16t squared?
14.
4t. So I'm going to go and add 4t to it because it's a positive, and I distribute. 4t times 4t is 16t squared. 4t times 1 is 4t. And then I subtract, right? Subtract, subtract. 16t squared minus 16t squared, gone. I don't have to worry about that. 0t minus 4t. Negative 4t. And then what do I do? Bring down the negative 1. See, step by step. And then go ahead. The last thing, what are you going to do? Negative 1. Very good. Because 4t times what is negative 4t? Only negative 1 left. And you distribute that. Don't you have negative 4t and negative 1? If you're going to be subtracting, you know your answer is going to be 0. So your remainder is 0. You don't have to attach to it. So your final answer for this is t squared plus 4t minus 1. Question on that. Okay? So long division, like I said, nothing more than just a regular long division problem. Just got to watch out for missing terms. If anything is missing, you got to fill it in. So just a quick quiz here, see if you actually spot any missing terms. What if I have the following? Oh, by the way, it has to be in order too. It's not in order, you got to organize it. What's missing?
4 and 3.
The 4 and 3. So if you're going to write this, it's going to look like this. 3t fifth plus 0 t to the 4th plus 0 t to the 3rd plus 7t squared plus 4t minus 2. Everything has to be accounted for. 5, 4, 3, 2, 1, none. See it? So please, check every single time. Do I have everything counted? If it's not there, I fill it in with a 0 and that particular term. We're good? Okay. With that, let's go ahead and give you your quiz for today.